Hi everyone. So welcome to a special presentation today, uh, where we will use what we saw in the previous streams to discuss about file format design. Let's see if everything works. Yes. And very importantly, I want to speak about file format designs, not data structure. It's not about so basically we will work on three formats that we covered in previous streams: PNG, GIF, and P6. And very importantly, this is not about, I mean, the fact that these three are about storing pixel data, so with image, with height, RGB, and they are lossless. It sounds, we can ignore this part. It's not about the structure, it's not about the algorithm, it's not about that PNG use deflate. P6 either stores or use a run length encoding, or GIF use Lampel zip Welsh. It's not about this. It's not about the way to display the picture. It's about the file format itself, the design's decision behind the file format. And for that, I think, I mean, so just to, if in case you didn't know, I've been malware analyst for like 20 years. I've been doing reverse engineering for 30 something years, always looking at files in hex editors. And nowadays I've been working on file formats, and also the Magica, AI file format filter at Google, which is open source. And for that, I started, Magica is used in production on Gmail and so on, scanning hundreds of billions of files a week. And basically, Magica sees the landscape of what's out there, like all the file formats, whatever file are going through. And so that's my perspective on file format, not just one file format. So of course, if you want to just create your own file format about something, why not? Do what you want, or more or less. But some formats are very hard, or if not impossible, to identify, to parse, and so on. And there are many examples, either very old or even more very recent. And which is why I'm talking here about a file format that would be a standard, because standard formats are forever. So whatever problem you leave them with, uh, it's forever, and it will be a hassle, for like, yeah, definitely forever, unless hopefully GIF will die, but not there yet. So what makes a good file format first is, I'm checking if there are answers, if there are questions, by the way, so feel free to ask them. My Clear identification, like a magic of some kind, with error checking if possible, and that leaves room for little or no FPs. I mean, you can be clever. You could start your file with my format, but then you will have maybe a company somewhere that is called myformat.com, and all their JavaScript will start with my format. And so if there is not something that prevents a false positive, like inserting a non-ASCII character early in the file, then you could have troubles. And remember that when it's about volume, people want to do scanning very fast, which is why either they use file libmagic, which just identifies a few bytes. And the problem is that when the signature is only made of ASCII files, then these bytes will match in pure text files. So, and yeah, so when I said error checking, I was referring to clear identification again. So we can see now, PNG starts with the PNG letters very early in the file, and with a character that is non-ASCII, which is unlikely to appear in a non in a text file. GIF starts with does start with the ASCII, 6 characters of ASCII. So it could be, if you start with a text file with GIF 98A or 97A, then it might be that this file is identified, especially because even if libmagic is not the worst file identification library out there, there are even simpler functionality libraries that just identifies that can only identify a few bytes, no pointers and no operators like this. And P6 sadly decided to start with absolutely no magic, so that could be an FP in other kinds of file. And even as we saw in the last stream, the version is not properly used, uh, like according to the specification. So let's go back anyway. So you want again, why do you want a good file format that are easy to identify in 2025? Well, even if you were aiming at the moon and you want something super clever like AI, well, you always need good training sets for AI. So basically, you need at some point an easy way to identify the files, and the easier the better, the easier the training sets will be to be created. And I know what I'm talking about here. So basically, it's funny that AI can help, but for the people who make the AI part, then it's still a problem. And again, standard formats are forever. So proper versioning is very important, because you never know how things might evolve. And so a way to make sure that the versions are easy to identify, not be guessed via crazy heuristics, and homogeneity, like is it really respected among the software out there. And my suggestion would be to that the new version, like when you have to create a v2, break something that will be rejected by v1, so that it's clear that it's not just an extension that has to be detected in some ways or whatever. Another thing that is hopefully from the past, but it's sadly present in P6, no hard-coded offsets. Don't say, hey, data will start at offset 80 or whatever, because then people will just expect the data to be always there. And that's then it can lead to surprise if you actually move the data because there is a new version. Then what if you put two sets of data, one at the hard-coded offset and one at the other? And it's a bit the same. Of course, some file formats use pointers, very rarely in pictures, or almost never. Oh wait, I'm thinking, does BMP has a pointer? um, BMP, let's see, BMP, does BMP has a pointer? Yes, BMP has a pointer, indeed. And as we demonstrated with Ginfail, Coldwin in the past, this offset is very often the same, which leads to the problem that if you just expect every BMP that the offset to be 1C, then put some data at 1C and put no matter what, and put some other data further in the file and then change that offset. And if software decided to say, hey, it's a BMP, hey, let's jump at 1C, oh yes, there is my header, then they might ignore the pointer altogether. So which is why I'm saying that there shouldn't be, if what is variable should move, should change. So if there's a pointer, it should have different values. And that's the thing with different BMPs. You may always have, oh no, that's an old version of BMP, right? But if we look at BMP version 2 and version 3, if I recall correctly, indeed, you see that so in BMP 1, the width and height are very small. If you see, no, what was the difference? There is an no, it's okay. Oh, sorry, I'm wrong. I'm confusing two things. Okay, so the pointer is always uh, at the same place, and basically you could make that's what I said with breaking. Um, when you create a new version, this is a BMP5, this is a BMP3, and you should make it's even better if you break some compatibility so that people have to adapt with the new version rather than coming up with some bad heuristics. But again, we will see that formats like PNG don't have to, found a good way to prevent this kind of versioning by the chunk names. So Another important thing is proper structure hopping. What I call hopping is that, is it possible to just, if even if you don't know, if you can't parse the current structure, can you just go to the next? And that's actually a small problem with GIF, where if you remember, oh, not this one, let's look at another one. um do I have, yes, I need a GIF with a comment, or with GIF with data, but with a comment it's even better. So with a comment you have this length chunking of a length, then the comment, then another length, and basically if this goes through the whole file, so from the beginning of the comment you cannot know where you should jump to skip the comment entirely. And the problem with that is that if by any chance this comment is actually storing some malicious payload, like a, let's say a PHP, PHP payloads are usually very short. So, and you want to trim the commands, then you want, for security reasons, a way to quickly be able to remove entirely this superfluous structure. So you want to be able to trim the software, the file very quickly. And if you don't have a way to directly jump at the end of the structure, then this is making everything slower. And then you can just exhaust by putting a comment long enough. You can just exhaust some parser because it only has a few milliseconds to do its job, and then it will not trim the comment. You see, you get the idea. So basically, hopping like quickly, if you are not interested in the current structure you are parsing, then just go to the next one. If it's not in the file format, then it can be a problem, because again it will make it harder to remove unwanted elements, or to isolate unwanted element and maybe scan them. Okay, no questions. So well, of course there is always the classic bugs of sign unsigned numbers, and for that PNG just decided to ignore the highest bit altogether, which is not such a problem. And another thing that is a bit like hopping is very important to, it's important that the format has very clear terminators, like a way to easily go to the end of the file, and then to, so that it enables to trim appended data, or to scan it if required, and formats that have that are really definitely easier. But we will see that many image formats actually just say, hey, now it's pixel until the end. And yeah, what about hiding a payload in the pixel data, because that's entirely possible, of course. Now, another illusion when we want to make a standard file format is the simplicity. Is like, let's just make as simple as possible. And for that reason, for example, the quite okay format is extremely simple. You have a magic, you have a width, a height, channel and color space, and then data. And then there's an end marker. And the thing is, there is no room. This is a bit, it feels like the original MP3 frame based format without the ID3 header. And the problem with that is that um, then people will want to add the author name, the date, the whatever, the origin of the file, the checksum of the original file, or whatever. And if the format cannot be extended, then either it will be hacked or it will be forked as a subformat. So this is I think a big problem when you just want to define a standard, when you will come up with. So the koi is a very nice compression. I'm saying it the Japanese way, like carp, koi, quite okay format, quite okay image. It has a very clever compression, but as a format, if it doesn't leave any room for future compatibility, future evolution, like I said, versioning, metadata, or any of these things, then the day someone wants to add this, but then, hey, where do I store my user name and whatever? Then the people will hack on the format, and it will actually spawn a new format. So that's here are my thoughts about creating a good standard file format. And now we can go through the formats, the three standard ones, and we can then review each content. So each the definition. So as I mentioned before, the PNG has a very clever magic, maybe a bit too big, but at least prevents easily false positive because of the presence of 89 as the first byte. if you don't know, 89 is like the tab character 09 with the highest bit set. So basically, if you were transferring a PNG and you accidentally remove the highest bits, then you would end up with the tab PNG, which would be very visible. Tab would typically create many spaces, so that would be very easy to spot. And the 0D0A mixes are mixing Linux and Windows new lines and carrier return. So line feed and carrier return. Sorry. So a very good way to see if by accident the file was transmitted as text according to one of these formats. And then there is a 1A in the middle, which meant file end of file in the case of DOS files. So basically, if you would cat show the output of the file, the display would stop there because of the 1A, and you would immediately spot it. And then there is in the case of GIF, there is a simpler signature on ASCII only, and the three next characters. I mean, it's difficult to say if it's a magic of 6 bytes. It exists in 86, 87, and 89 version. And the thing is, nowadays they don't care if it's a 86 or 89. The 89 is the one that, do I have it? The 81, the 989 added introduced the comments possible extension blocks. But in any case, it doesn't matter if you just put 87. Just parsers will be okay with that. So basically, it makes the versioning of a GIF nowadays useless. And this is a 6-byte, quite a long magic, but yeah, just pure ASCII. So it could lead to false positive easily. P6 had a very bad idea. Again, this is the oldest of the format of these formats here. P6 is from 84. P6 just start with a supposedly variable value of for the manufacturer, but in practice it was just zsoft 0A 10. And the problem is that this is even worse. It's like it's a typical text character. So if you have a file that starts with a new line, then it's possible that you would have a false positive if by any chance your detection is so crappy that it only checks the magic of the P6. So if we look at other formats, BMP has start with a BM. Okay, same problem again, but very early it starts with the non-null bytes, so that should be okay. But again, something non-ASCII in the magic, it doesn't hurt. And KOI, I mean, quite okay for image format. Start with the 4-byte ASCII magic, and now sadly, and only a lowercase. Bigger risk of false positive, sadly, in general. BPG from Fabrice Bellard start with BPG and then FB as a hex, his initials, which is pretty clever, and that's a good magic. And I should just show MP4 here because JPEG-2 files are using the same structure, and JPEG-2 they don't start with the magic; they start with the length and possibly ftip file type in the first, and then the file type here would be JP space 2 or JP2 space in the case of a JPEG 2000. So now, mention, yeah, very good, clever PNG signature. Now the overall structure. In the case of PNG, the structure is not only very clever, but it's very regular, and it's always very easy to hop over the next structure. So basically, it's made of a sequence of chunk. Each chunk starts with the size and the ID. If it's higher, if it's uppercase, the first letter is uppercase, then the chunk is critical. So it should be parsed correctly by your parser. If it's lowercase, then it can be ignored. And if you can ignore it, then just take the size and just hop to the next chunk, and so on until the end of file. So basically, it's extremely simple to jump until the end of file in a PNG. It's very simple to jump over the whole structure, all the structures of a PNG, to determine if you can actually render it, if you are able to handle all the critical chunks or not. GIF, is using weirdly, I mean, it's interesting, it's a bit old school. So it has a local, it has a header. Then let's see with this one, then the palette is following. Even in case of global palette, the palette is following directly the header, but still it's a sequence. And then the sequence are limited with a punctuation, so question marks for extension blocks, comma for image descriptor, and a semicolon for the terminator. And the other, so it's a sequence, so it's not difficult to go through. But the thing is, you don't know, you don't know you cannot jump immediately to the end of the command, as I mentioned before. You need to hop each chunk. And a chunk, because the length of a chunk is over a byte, you need to basically uh, most early first chunks, except the last one, would be usually to 255. But it could just be different. And the problem is that if by any chance a chunk is shorter, then if you land in the middle of the data of a chunk, then there's nothing that prevents this byte itself to be interpreted as a chunk length. So basically, you actually need to go to repeat that loop for every chunk, every 256 bytes maximum. um, and I wanted to also mention, I lost my JPEG diagram. Another problem. So basically, at least with this algorithm, you can easily go to the end of a GIF file. And PCX has this very weird situation where the header starts at offset 0, okay? Then it resumes at offset 40, because in between, that's where something like EGA palette was big enough to fit, even though you might work without a palette altogether. So basically, the header resumes there, and then after this header, there is still some extra space between 50 and 7F. Usually, there's nothing, and at 80 is a hard-coded offset for the data, which is like pretty crazy because, yeah, I mean, why this space, why this wasn't reorganized. And the craziest part again is that there is a version number, so why not creating a new version number that is reorganizing the whole date, every all the data? No, they never did that. And if we look at p6 for 256 of VGA palette, VGA images, then again the data starts at 80. The data between 0 and 40 uh, might not be used at all. And in this case, they added a hack to you have to append the palette to the image data after a 0C marker, no matter the length of the palette. And so basically, this is very weird because it makes it extremely clunky to actually locate where the data is. And maybe it's a problem if you put two palettes, like you one right after the data and another one at the end of the file. There could be two palettes, there could be ambiguity. It's a very it's crazy that it's such a nice format close to the hardware, but then to parse and avoid ambiguity, it's just very complex. So the P6 managed to to be an example of, it should be simple because it's close to the hardware and the hardware dictates for the data format basically. But nope, it's a full of weirdness, empty spaces, and headers that resumes at offset 40 or whatever. I just mentioned the JPEG. I didn't get the JPEG file. Let's see. The JPEG file has this other weirdness that it starts with FFD8, it starts with signature, then most chunks start with the size. So you have FFE0, then a length, FFDB, and a length, and so on. But for the actual image data itself, okay, we will. Then there is this weirdness that the length is just the length of the parameters for what is called the scans for the image data. So just the parameters are counted in the length, and then you just need to parse until the image is done. But the shortcut for JPEG is the FF character, where every segment starts with the ff byte and followed by a non-null byte. And a non-null byte means that if you have to encode an ff in the image data, then it should be followed with 0 to say this is a literal ff and not a segment. Basically, once you are ffda, you skip over this length, so 8 bytes, and then if you wanted to not parse the file, to render the image, but just look for where the end is, you just keep on looking for an ff not followed by 0. And when it's ffd9, it's the end of file, because the scan could be split into several scans. I mean, for usual reason, progressive images, So basically, at the end, you end up with you would have to still go through the whole data, or you just directly look for ffd9. But if you just wanted to go to the end of that scan, then it's a problem. There is no way to directly know um where to jump to skip this part. So basically, I could use that trick to ffda. Then at the end of the scan, I put a comment fff0 fe, and then I put some payload here, and maybe your algorithm will skip scanning this payload entirely. So as you see, a common problem of being able to hop over structures until and to be able to scan or train them, And as I mentioned, it's important to be able to store metadata. Not only PNG has many ways. It has 3 official text commands: standard, Unicode, and zlib compressed. But you can also create yours without any problem. So no problem with metadata in PNG. A GIF has the ability to store comments, but also you can add your own extension block. And in any case, every extension block follow the chunking structure. So basically, whatever will be after, even if you use you put a function like a value to define your extension block as something non-standard, then every extension block is supposed to use subblocks like chunking. So basically, you can still hop over the data of a known extension block. NP6 has absolutely nothing for metadata, like Koi. BPG has some way to put some extension. There is a flag to put extension, and this is exactly how we make the polyglots with BPG. But Koi doesn't have such a thing. So yeah. Chunking. The reason, so you can chunk stuff in JPEG to do progressive, progressive store decoding, which means progressive decoding means there is the first scan that will create a low resolution image of the image and a version of the image, and each scan, when rendered, will add more detail to the image. So in the case of PNG, you can actually cut the image data, even though it's always in zlib, so that you can decompress every IDAT chunk in parallel. But the case of GIF, the case of chunking for GIF was different. It meant that at the time nobody had much memory, and that way the file could be written on the fly, even though it had an unknown length in advance. I mean, definitely the GIF could be written on the fly, not looking, stepping back, moving backward to you at this time. It was very common to save data on the fly, not you couldn't prepare it in memory and then save it at once. It would be too slow if you were on a floppy drive or something. I mentioned in the PNG file, you have this very strong marker. It's a chunk again, extremely strong marker, always the same. But to be honest, you can, even if you remove this marker, then it's pretty clear that the image data is over because there's a length for the image data and there's a CSC32. So even if you remove the image end marker, then the file will very likely be considered valid. In the case of GIF, the termination is easy too. I mean, there's just the problem of zip, but of hopping over the chunking, not zip, of course. And there's the terminator is a single character semicolon, which is okayish, and usually followed by zero because it's finishing the last chunk. And sadly, in P6, okay, the advantage is that P6 is easy to parse altogether, but if your P6 is using a run length encoding, then it might be a problem to determine when the end of image data is, especially if there is a palette appended to it. So P6 definitely not an easy format to parse. They're not definitely not a good example of format to parse. PNG. So about landscape homogeneity, what's the outcome of all this stuff? PNG was born with a specification before being a format being used. And homogeneity of PNG is very good. Most of parser behave the same. There is just this tiny difference that CRCs are enforced for image header and not the other one. You can have parallel decompression for when image data has been chunked, and there is even room to create new subformat like the CgBI that I mentioned in a stream number 4. A CgBI being a CgBI being an Apple uh, iPhone optimized PNG where um, the pixels order, and there is some optimization so that the rendering is faster. But the good thing is that here, by just creating a chunk that has a different name, that has a uppercase C, then so non-Apple software will just refuse to open it, and at least it's very clear that your format is different, even though it's following the same overall structure. So CGBI core graphics um, um, bitmaps, so that's official name of CGBI PNG, are a clear example that PNG formats like PNG are ready for the future, even if people want to create their own new version based on it. So very clear. GIF is creating a lot of problems because typically when GIF is used on the web, and the web is a source of many abuses and crazy behaviors and incomplete software. So basically, uh, even if looping in the GIF is not a standard, even if looping in a GIF is not a standard extension, if you saw my stream on the GIF format, it's the Netscape 2.0 extension for looping. But most browser will just say, hey, this GIF is pretty short. Hey, it only has this size and this amount of frames. So let's put for looping anyway. And if there is, oh, this delay looks wrong, let me ignore it altogether. Even though initially null frames could be used to put two pictures at the same time to be able to display more colors. In the case of GIF, typically browsers ignore these parameters and have a very, very different rendering. So basically, test your GIF files with viewers as well as browsers. The result might be very different and abusable. And P6, yeah, it's the problem. The versioning is it's like the specs don't really exist, and offsets are hard coded. So yeah, it's not the best format. But now, so the good thing, which one is harder to abuse? It's this, which is interesting, is that because of the chaos created by P6, reliably, because the format is chaotic, the landscape of the behind around the format is chaotic, then the abuses are chaotic. While with the PNG tricks, it's very clear that if you put a command chunk in a PNG, every parser will support it, will ignore the content. So it's pretty funny that it makes abuses very harder when the landscape is chaotic. The landscape of parser and versioning is chaotic, but in the end, it's still a good thing, because it's still a bad thing, because if the PNG is easier to parse, then it's easier to test for security. You just need one interpretation of the PNG if you want to trim all the unknown chunks, if you want to scan them. So the, it sounds like an easier target, because you will have a wider impact, but so will your security software, your scanning, your develop, your ideas. So basically, it's crazy that, I mean, it can sound crazy that if you have a chaotic landscape, it makes abuses harder, but just because everything is unpredictable. And this is exactly why, when we did the shattered hash collisions, we abused JPEG in the PDF, because the landscape of PDF parser is so different from one parser to the other, so that if you want to abuse something, it was easier to abuse JPEGs files inside within a PDF, because they all behave the same regarding PDF, while they were all behaving differently, with little differences on the PDF side. Thanks for your efforts. Here, I hear a lot from your posters on GitHub. You're welcome. So, as you could see, uh, all formats are old school. I mean, all formats are were written on the fly, were very minimal in their overall structure, and initially were not defined with the proper specification, and maybe not well thought. Modern formats like PNG were properly defined first, and yeah, with quite a clever specification, like good stuff. And now I would hope that in the future of file formats, it's even better, more like the cryptography, the world of cryptography, where you have test cases and test implementation, test vectors. A question from Rinaldas. Unrelated question. How do you go about learning all these file formats? Just online, the specification, the discussion, the community. There is no, I mean, my website. Um, yeah, no, there's no hidden trick. I have a few file books here, but uh, yeah, websites like Just Solve, digital preservation knowledge base, even though they are usually quite limited. So yeah, I'm not sure I have a very big to answer that question. I'm not sure I have a very secret answer. It's just time and a good memory or passion for it, and being at Google for almost 10 years, and having worked on all kind of file format problems over the years, I guess that helps. So, and another point I wanted to address is that, is P6 clunky because it's hardware oriented? You know, P6 with this, oh, let's put some stuff here, oh, let's put the palette, now let's resume the header, and let's put, no, 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 no. This is unrelated, right? In the end, it's just storing a palette and bit planes, like the hardware. And if you realize, this is exactly what CgBI, where's my CgBI? What CgBI PNG is about. They created a new chunk, and then the image data is following another format. So it's not because one is hardware oriented and the other is not. Nothing would prevent you to do to create a new three new chunks in the style of PNG: one EGA header, EGA palette, and EGA bitmap or data, and then to store the exact same data, and you could even compress it in the case of a PNG. So it's not because one is hardware oriented and the other is not. It's not because one is hardware oriented and the other is stored in a generic way, that it doesn't prevent you to do your new PNG spin-off, exactly like Apple demonstrated with the core graphics bitmaps. So I think that's all I have for you today. Um, the PNG. So as you see, the BPG is very compact. The length, the width, and the height are stored in a variable length. So that's why they are not necessarily easy to read. And then there is a picture data length, and you can say until the end of file, and that's about it. Oh, I forgot that you could encode it. Maybe you could set something afterwards. But anyway, it's not a widespread format. But at least it's a format where you could put some extension, and therefore you could put some metadata, whatever, no matter the format, or polyglot, or hidden payload, or anything. And quite okay image formats, on the other hand, has no room for anything like metadata, which is a problem, because if it gets traction, then people will say, hey, where do I put my data? So yes, I think that's all I have for you today, and I thank you all for your attention. Having one last look for the questions, and if no question, then see you next stream. Bye bye, everyone. Thank you.